In this video, we're going to work through another example of writing a paragraph about an element. So the first thing that we're going to do is find phosphorus on the periodic table, and phosphorus is number 15 on the periodic table, and it's listed here. So we would have phosphorus. We would start the paragraph by writing phosphorus is. Now, technically, as we mentioned, it's really atomic number, not just any number, but that atomic number indicates something to us. And I'm using the model of our previous paragraphs that we wrote. Sodium was number 11 because, and here we're going to go phosphorus is number 15. So phosphorus is atomic number 15 because every atom, and I'm just following this paragraph here, the model, because every atom of phosphorus, has 15 protons. Every atom of phosphorus has 15 protons. That's why it's atomic number 15. And where are those protons located? 15 protons in the nucleus. 15 protons located in the nucleus. And the atomic number gives us two pieces of information: the number of protons in the nucleus and the number of electrons, and 15 electrons. And I like this word here, arranged. These electrons are not randomly placed around in the outer part of the atom. They're arranged in energy levels. 15 electrons arranged outside the nucleus. The inner part of the atom is called the nucleus. The outer part is the electron cloud. These 15 electrons are arranged outside the nucleus in the electron cloud. That gives us a good indication of the overall structure of the atom. Inside the very tiny nucleus are 15 protons. Arranged outside the nucleus in the electron cloud are 15 electrons. Phosphorus is also located. Phosphorus is also located in column. So now we're going outside of this box. First thing, we found out that it was number 15. That gives us the number of protons, the number of electrons. Protons in the nucleus, electrons in the electron cloud. Then here, column 5A. So column 5A and row. So we got column 5A, columns going up and down, and row 3. Column 5A and row 3. Why is it in column 5A and row 3? Because every atom of phosphorus, has, now we're going back to the column number, has 5 of those 15. So of the 15 electrons, 5 of those 15 electrons, all alone, and I forgot the word electrons, 5 of those 15 electrons, all alone in energy level number, and the energy level comes from the row that it's in, energy level number 3. The column 5A tells us that we are going to have 5 electrons on the outside, or 5 bonding electrons, or 5 valence electrons. The row number 3 tells us that we are going to have 3 energy levels. The column number tells us the number of outer electrons. The row number tells us how many energy levels we have. So when we go to draw this atom, what we said is if it's 21 or more, we're just going to write the number with a P in the plus. If it's 20 or less, we're actually going to draw the protons. So I'm going to draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 protons in the nucleus, all packed tightly together in a very small area of space. Then I'm going to find out how many different energy levels I have, and there are 3. 1, 2, 3 different energy levels, 3 different areas of space in that spherical atom. You can think of the first one like the surface of a ping pong ball, then the surface of a tennis ball, then the surface of a softball, and the electrons are flying around in 3-dimensional shapes. Well, how are the electrons arranged? How are those electrons arranged? We know that 5 of them, because it's in column 5A, are on the outer part of the atom. 1, 2, 3, 4, 5. 5 electrons on the outer part, all alone in energy level number 3. Well, we know we have 15 electrons and 5 of them are on the outside, so that means we have 10 more. Do we just put 5 in one energy level and 5 in the other? No, no, no. We have to follow our pattern. So we're working our way until we get all the way to phosphorus. So we roll the dice, we roll a 15, and we're working our way, moving our little Monopoly piece until we get to 15. So in energy level number 1, which means energy level number 1, I count over 1, 2 spaces. So I'm putting 2 electrons in energy level number 1. They're flying around on the surface of that ping pong ball. Then we go to energy level number 2. I counted 1, I counted 2. Now I'm in energy level number 2, which is the second energy level. And I'm counting across 1, 2, 3, 4, 5, 6, 7, 8. Because I counted across 8 in energy level number 2, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 electrons in energy level number 2. This first energy level matches with row 1. The second energy level matches with row 2. The third energy level matches with row 3. And in row 3, the third row, I count over 1, 2, 3, 4, 5. It's the 5th one over. That's why it's in column 5A. It's the 5th one over. So 1, 2, 3, 4, and 5. We call these electrons. Electrons are bonding electrons or valence electrons, also called outer electrons. All of those terms are for these 5 electrons. 5 electrons on the outside. These are the different areas of space called the energy levels. Because it was in row number 3, there were 3 energy levels. Because it's in column 5A, there are 5 electrons on the outside, 5 valence electrons, 5 bonding electrons. Why are the outer electrons so important? Because as one atom flies around and it connects with, bumps into, sticks with, or bonds with another atom, it's the outer part of the atom that is the most important part. That's the part that's connecting or sticking together with or bonding with other atoms. That's why the outer side is so important. I hope this helps in understanding columns and rows and the meaning that they give to us regarding the structure of the atom.